Hey, hello. It's exciting. We're on the air. Welcome to our...
Before joining MathWorks, I spent about 10 years working in the automotive industry. So today, along with Teresa, I want to share some of the stories and some of the information that I have gathered while doing this. So hopefully that will help you understand and use Stateflow better.
Yeah. So we're excited to be here. We're excited to be here with you. So this is live. We're really looking forward to interacting with you and getting questions and comments. So we're looking forward to that. So first, we're just going to give you a sense of what we're going to do today, and then we're going to jump into it. So did you want to do the agenda, or should I?
Go ahead.
I'll do it. OK. So we're going to give an overview of an example application. This is your favorite, right? The battery management system application. We're going to talk about how we see Stateflow being used in the wild. What is a state machine? We're going to go in, so you'll know pretty deeply what a state machine is after this, or as deeply as I explain it. You're going to build, or I'm going to build a state machine from scratch. We're going to talk about when to use Stateflow instead of Simulink or MATLAB, right? That's a question we often get.
Yeah, that's a very important question.
When do I switch? Yep. Yeah. We're going to talk about adding flowcharts to our model. We're actually going to do the adding of the flowchart to the model. And then we're going to do, we're going to add a state machine as a table to our model as well. So, OK, a lot to look forward to. I guess we'll dive right in. Did you want to? OK, great.
Yep. OK, so as Teresa said, we're going to start with an overview of an example application. And first, I want to mention that state machines are everywhere. Maybe you realize this, maybe you don't. But let's start with a simple one, traffic light. I'm thinking that everybody must have seen a traffic light. And if you think about it, it has three states, right? It has green, go, yellow, be cautious, and red, stop. That's a very simple state machine. Speaking of traffic lights, you also have tons of state machines inside cars, airplanes, trains. Actually, rocket science has a lot of state machines. All sorts of industrial applications. But they are not confined only to things that move or means of transportation. You can find them in all sorts of industrial applications. You can even find them closer to home or inside your home. Many of the appliances that people have will have some sort of state machine.
I think we have a good user story about using an oven with a controller system using Stateflow in it.
Oh, really?
Yeah, or it's either that or a dishwashing machine.
Yeah, I mean, whatever it is, there are tons of applications for state machines in electrodomestic appliances, also in medical devices. And one last thing where they are very prevalent, and this is also very common in many of these applications as well, is in batteries. And that's why today we are going to be focusing on how state machines are applied to batteries, or more specifically, to battery management system. But what is exactly a battery management system, or BMS? Basically, it's just a device that monitors and controls the state of a battery. There are simple ones. At a core level, they will monitor current, voltage, and temperature of the battery to try to determine how much energy is in the battery and what the battery can do. And today, we're going to be looking at how these state machines are integrated in BMS. What's the plural of BMS? BMSs?
BMSs?
Yes.
That sounds wrong.
Yeah.
BMSI?
Yeah. Anyway, our BMS will have three main states: standby, meaning no current in either direction; charging, current flowing into the battery; and driving, current flowing out of the battery.
Oh.
So we're going to be looking at this implementation of a BMS.
We're not going to build this whole thing, right? This is too big a model for us to...
Right. Yeah, that's a very good point. I'm getting a little bit ahead of myself, maybe.
No, it wasn't a correct.
Yeah. No, we're definitely not building this here. This is a sophisticated BMS that also has a lot of pieces that don't necessarily involve Stateflow. So we're just going to walk through the example that we have here, and we are going to recreate parts of this BMS for you to see how easy it is to do it, but also how powerful Stateflow is and how it will help you during this process.
OK.
So here, we will see that we have three main components at the top level, starting with the test scenarios that will produce the input that is used by the other two components here. The BMS algorithms, it's what we will focus on for today, contains the software, and the plant model. Inside the BMS algorithms, we will notice additional software components, starting with the current power limit calculation. As the name implies, it will try to estimate how much current can we put in or out of the battery at any given condition. Then we're going to have the fault detection that is going to try to determine if there is any negative situation that will affect the battery. And this information is going to be sent to the state machines, which in a way are the core of this algorithm, and we're going to look at them in more detail in just a second. But after the state machines, we have the SOC estimation, state of charge, that is basically going to try to determine how much juice is left in the battery at any given point. And lastly, for this algorithm, we are going to have the cell balancing. Because batteries are composed of many different cells, we need to make sure that the voltages of these cells are as close to each other as possible in order to extend the life of the battery.
So this state machines thing, this is what we're going to focus on today.
Right, the state machines are going to be our focus. The first one is this contactor management, just handles the state of the inverter and charger contactors. Then we are going to have the BMS state, which handles the overall state of the software. And this is what we're going to be building today, or well, you are going to be building today.
That's still true.
And finally, we have the charge management that will determine how much current we need to put into the battery and under which conditions we're going to do it.
Okay.
And from there, Teresa, take it away.
All right, so I'm going to be building the simple state machine, but first I'm going to start off with what is a state machine. So I hope some of you are new to this and you're getting some new information. Basically, a state machine is about modeling states. Well, it's in the name. And it's the state or mode of operation that a system can be in and how you transition between those states. And that might occur based on event or based off of some data coming in as an input. So in this example, and this is a part of what we're going to be building today, we're going to have a standby state, a charging state, and a driving state. If you remember, that's what Eric said at the beginning. Those are the three states we're going to have. So we're going to have some request coming in telling us whether we're going to move into a charging state or a driving state. Otherwise, we're in standby. And then we're going to add a fault state. So if we're falling into some sort of critical fault path, we would go into that state as well. Instead of charging or driving, you don't want to be driving with some sort of issue going on.
No, definitely not.
Yeah, so we're going to have, and in this case, this is going to be, we're going to take in sensor data. So for our example, we'll be using the temperature of the battery and checking whether it's dropped below a threshold. In our case, it's negative 15 degrees. And then once it's above that threshold, we can go back into standby. Yep. That's kind of a basic idea of what we're going to be building. And all state machines have three parts. They have states, so the circles, the things that, the state that we're in, the mode of operation, the transitions between them, and then actions. And actions, in this case, are going to all be inside the state, but sometimes they could also be on transitions. We'll see an example of that later.
And before we move further, I just want to say, like, I'm so happy in the way that you explain state machines. Oh. This is way simpler, much more easier to understand than the way that they were explained to me when I was in university.
Oh, I know.
As this very abstract thing that is so difficult to comprehend.
Lots of rules.
Yeah.
This is it's a. But if you think about what are the main components, it really just comes down to that. So, what I've done is I've taken that hand-drawn example and I've turned it into a Stateflow chart, and you can see it maps pretty closely. And the reason why I want to do this is because I want to be able to simulate it. I want to be able to run it and change my inputs and look at how it responds. So that's what we use Stateflow for, is to move these designs into something that we can run, test, and eventually generate code from. So we have states here. These rectangles are like our circles before. We have the transition, the blue line with the conditional statement on it. That's a transition. So in this case, I'm in the standby state, and I'm checking to see what my state request is. If it's equal to 2, I go into the driving state. So that's a transition. And we have actions. So once I enter a state where it says entry colon, that means that I'm going to do some sort of action. And in this case, I'm going to send out my state. I would have to say that usually you can do state logging to send out the state of your state, but I don't know. I just do it this way this time. but there is another way to do it that you don't always have to just send out your state. So anyway, this is what we're going to be building. The other thing I should say is that for our examples, and when we're going to be talking about Stateflow, it lives inside Simulink. So it's getting input data from Simulink, and it's sending output data to Simulink, correct?
Yep, that makes a lot of sense. I think for people who are already familiar with Simulink, this will make them understand where Stateflow is placed within this whole environment.
Yeah, and if you're not used to it, you need to remember that you're that there is a place you're getting the input data from and the output data goes to. So let's see this in action. So what I'm going to be doing is building it. The first thing I'm going to do is go to the Simulink start page. And on this page, there's a lot of templates you can get to start with. I'm going to just pick the simple state flowchart because I like its name, simple state flowchart. Yep. Yeah.
Also, while that opens, I just noticed that your UI looks a little bit different from what I was showing before.
Oh, yeah. So what I'm using right here is the MATLAB Online. So I'm building everything inside of a browser. So this might look a little different than what you're used to for people on the desktop. So what I've got here in the simple state machine is I have a default transition, that blue filled in dot going into the state. That is my default. I'm going to start in state 1, and it has a condition to go into another state, state 2. So 2 states. U is my input, so that's coming in through this sine wave, and Y is my output. So it's inside a state. It's inside a Simulink diagram. And I'm going to go ahead and just build it out with the 2 states first. I'll start with standby, and then I'm going to do the charging state on the other side. OK, so just a second. Here we go. Charging. OK, so we have the 2 states, and we can all the stuff with the green after the percentages. That's just comments in case you weren't aware. But it's just trying to help me get a sense of what these things are. So on entry, Y is equal to -1 in standby and 1 in charging. I want to change that, so it's going to be the state that I'm in. I want to report that out, and we had a special way of calling that. I think it's BMS state, so I'll go ahead and write that. OK. Oop.
BMS set.
Yeah, state. OK. It's equal to 1, and then I'm going to go, or 0, sorry, on standby. And then on charging, I'm going to set it to 1. OK, here we go. You might notice up in the symbols pane, if you look up to the right over there, it says BMS standby already with the stop sign with an exclamation point. I'll show you that a little bit later. But what's going on is, and you'll now see that Y has a caution sign. So what happened is Y is not being used anymore in the model, so it gave me the caution sign on it. And the BMS state is used in the model, but not defined in the symbols pane. So I'll have to fix that in a second. And then the next one is the state request. I'm going to be kind of goofy about this at the beginning. I'm just going to say if I have a state request that's not 0 or less than 0, I'll just go into the charging state. So I'll start that way and get rid of this comment just because it's bothering me. OK. So, and down here, I'm going to go ahead and set state request to greater or equal, or less than or equal to 0. OK. So now at this point, I'm going to do some magic, and we're going to go into the symbols pane in a second here. OK, there we go. So here, what I wanted to show, I want to make it clear what I'm looking at here. So the squares with the arrow going into it is showing that it's an input, and it picks it up. So Stateflow is pretty smart about catching what your data is doing, and it knows that that's an input, and then it knows that the BMS state is an output. So it's proposing that I go ahead and make it an input, and then this one I'm going to make an output. And what it's going to do, you'll see when we go to the Simulink model, this change is going to change up my Simulink model on the top. So
that's pretty cool.
yeah, it catches. It's helping me figure out what my inputs and outputs should be as I go. So I use this symbols pane pretty heavily. This is my main technique for that.
Yep, and I noticed that you also got rid of U and Y, right? Which we were not using anymore.
Yeah, yeah. So the caution signs let me know there's some sort of problem with that. The truth is I didn't want it anymore, so I got rid of it. So just tossed it. Okay, so I'm putting in a fault state now so we can get in that other type of condition. So I'm going to have the BMS state sent out here as well. I'm going to set that to -1. Just, I don't know. If standby 0, I guess this is worse. So -1. And I'm going to go ahead and resize that. I do, you want all your content to be within the state, so it's a little bit of futzing with the size once in a while. You notice that was yellow when I pulled off of that. Now you see the
warning sign.
Warning sign, yeah, that means that it's not reachable. So I need to set up some sort of transition into it so it becomes reachable, and I'll go ahead and check my battery temperature. I want to check if it's less than -15 degrees. And then if so, move into the fault state. And from the fault state, I'm going to want to go back into standby. Actually, I'm going to first check whether the temperature's less than -15 here too, and then go into fault.
And one thing that I really love about Stateflow with this process is that every time that it notices something that looks odd, it will tell you like, hey, aren't you forgetting something? Aren't you forgetting to transition to this state?
Yeah.
Aren't you forgetting to define temp battery?
Yeah, it helps you out a lot, yeah. For something so graphical, it helps when you get a lot of clues. And the environment does give you a lot of clues here. And so I'm also going to, we need to be able to get out of fault too. So I'll just set the if the temperature is greater than or equal to -13, I'll go ahead and go back.
Yes, so some Easter eggs here to make sure that we're not going between standby and fault all the time, right?
Yeah. We don't want to bounce. We don't want to bounce. So, okay. The other thing I want to point out is like the numbers on those transition lines. So those mean something. That means that this one's getting checked second. And for safety's sake, I don't want this checking second. I want it checking first. I want to move immediately out of charging if the temperature is too low. So I went ahead and changed the priority order. So you can change the order in which the checking occurs. And those numbers are giving you a clue as to what the order is. So let me go ahead in the symbols pane. I'm going to just fix that with the temperature of the battery. I should have said, there's a button there that says fix all of them at once. That the little there's a the red button above state request there. I could have chose that to like change all of them at once, but anyway, I did it one at a time because that's my habit. So here's the driving. I'm going to check here on the state. I'm just going to check, or I'm going to send my state information out, so I'll send it as 2 in this case. And I'm going to check the state request. And in this case, I think, obviously greater than 0 doesn't work when I've got 2. So I'm going to probably say that we're going to set the first one charging to be 1, a state request equal to 1, and the second one will be if it's equal to 2. So I'll just change all these around. State request in this case is going to equal 2, I think, at some point. There we go. Yep. And I'll check whether state request is equal to 1 on the other one. And then I'm going to just change it on the other things. But I like this about Stateflow, that you can change it up and make things. You evolve your design as you're going. You're not necessarily stuck with a particular design at the beginning, and then you can't move it. So iteration and changing things as you go along is very easy in this environment. So I think we're going to see a different approach how you do these things than just the fly-by-night way that I do it. But the fly-by-night way is what we're watching here. So working as you're doing it. So okay, so now we're checking whether state request is not equal to 2, and on the other side we're going to just do if it's not equal to 1.
Yeah, so that makes sense, because if you're transitioning from charging to driving, maybe it will not immediately be a state request of 2, it will first go into standby.
Yeah.
So yeah,
Yeah.
that makes sense to me.
Right. So, okay, so now all I need to do is set up one more transition to the fault to check whether the temperature of the battery is less than 15. And then I think we've managed to create the first chart. So
Yep.
Right.
What was it, like 10 minutes maybe to create this whole chart?
Yeah. So it's the it's my method of like figuring out how to do this very quickly. But yeah, but it's not too hard. Now, and here, this is the trick. Okay, so now I go into Simulink and I realize I need to fix things in Simulink because it's not going just one way. I'm going to do a little magic on these two here, but I'm going to go ahead and use a signal editor block. I like this block for just some quick test data that I want to send into my chart. So I'll set up a scenario here. I'm just going to call it first scenario. I'll add a signal to it. So let me go ahead and add actually it's going to add 2 because there was always one in there already. So the first one's going to be the state request that I want to send in. And then I'm going to send in the temperature battery, or battery temperature.
So I have a question here. If, let's say that, for example, you already had those signals, like, for example, in an Excel file or something.
Yeah.
Is there a way in which you could have imported this data from another source?
Yes. I could have, and I should have. So there's an import button there, and you could bring in data from MATLAB, or you could bring it in from Excel. But it seemed like easier to me at the time to just go through and add all these in. So I did the magic transition there, so you didn't have to see me do all of them. But anyway, I'm going from standby first in the state request to charging, and then to driving. And that happens around, I didn't catch the time. But anyway, it happens, there's a time. But I'm also going to change up the temperature of the battery. So the temperature of the battery is going to drop suddenly at the third time step to
minus 30?
Yeah, to minus 30. Which that's not realistic, is it? It's not really.
I think if you drive up to Montreal, you might find that. It's funny.
Oh, okay.
At some point, you're going to be in Montreal, and then you're moving to Arizona at plus 50.
Yeah. So, well, okay, it's a good test case. When I wrote minus 30, I was like, I'm not sure. But anyway, we're going to just check whether I'm going to do some animation on this. I'm going to set it to slow. And this is really a great thing about Stateflow, is that you can set it to slow and kind of watch it change as it's moving between states. And I can see I've got to the charging state and I moved to fault, but I didn't get to driving.
Right.
So I'm going to go change my inputs because I know it's because of how long I'm staying in the fault state that sort of kept me from moving into driving. So let me go back.
So you stayed too long in Montreal then?
Yeah.
Need to return to warmer temperatures.
It's like, you're not going to drive here. So let me move it up to negative 15. And okay, there we go. And now I'm going to go ahead and run this, apply it, and run it again. Okay, here we go. Should make the changes. Oh, sorry. And then I'm going to run it. Here we go.
So I'm really curious to see if we're going to driving state this time.
Yeah, me too. No, I can't. I know we are. All right, we got to charging, we got to standby, we got to driving. Yeah. All right. So we didn't drop low enough, for long enough that it took us out of that. So there we go. That's the build your own Stateflow chart. So now's a good time for us to pause for questions. I know that was a lot to take in if you've never seen Stateflow before. Any questions at this point? No? Okay,
No.
We're going to stop again. So just feel free to put comments, questions as we go. This one's for you. When you were working in industry, when did you use Stateflow instead of, or when to use Yeah, Stateflow instead of Simulink.
Yeah, well, I won't say, when did I know? I'm not sure. It's not a straightforward answer in all cases. Sometimes it was
Yeah.
more like, let's take a educated guess.
Right.
But I would say, very commonly, one way to
Well, sorry about that. I should have closed that up.
one way to know when it's a good idea to go to Stateflow over Simulink is when you have complicated logical operations, when you have lots of case statements in a switch case.
Hold on a second, guys. I'm going to just...
Or when you have complicated temporal logic as well. For example, in this case, we were dealing with several states, and the logic needs to remember in which state it is so that it will produce the right output. So in those cases, it can be done with Simulink, definitely. But it might not be as easy to scale it up later if you need to make any modification.
Sorry about that technical difficulty, but last thing you guys want is my colleagues pinging me on the as we're going along. Sorry about that. Okay, here we go. Let's try it again. There we go. Apologies.
Okay.
Now you know it's live, right? That was my bad. Okay, here we go. Let's try this. Okay.
Right. So here we have a good example of this. This is a very simple heater switch model. Basically, it will turn a heater on and off based on the input temperature that we have here. And we have the implementation in Stateflow, Simulink, and MATLAB just for fair comparison.
What the? How did that come back?
So let's look at the data of this. I just wanted to run the simulation first to show you that we're not tricking you. These things are actually doing the same thing. And it's very easy to see. On the top, we have the temperature. On the bottom, we have the three switch signals. They start at off when the temperature is high. And then, if we move the cursor a little bit, we will see that around the time that it hits 42 degrees, then the switch is going to go on. Then it heats up again. And by the time it goes around 43 degrees, then it will turn off once more. So now we know that they are all behaving the same way. And if we go into the Stateflow implementation, really, if you look at this.
Oh my gosh, hold on a second.
This
I apologize. Hold on, I got to stop this because I don't know what's going to pop up next. So, sorry about this. I apologize. That was. I think I have to reset. I have to be not disturb, right?
maybe, yeah,
Sorry.
not disturb or just right click on the Teams and close it.
No, I
quit.
did that. That's
Oh.
why it was. Now I have to reopen Teams to like say don't disturb me.
Wow. Well, apologies for that, folks. We're doing our best to get over these technical difficulties.
Yeah, it's such a silly
Um,
technical. Yeah, okay, set my desktop to do not disturb. Okay, well, all right. I think I closed at least Teams to not say do not disturb. We'll see if that works. Okay, here we go. Let's go back. I apologize, Eric. I'm going to go ahead and present again. Okay, go ahead. Should I restart this? Or what do you want?
Maybe let's
jump
go
ahead?
jump ahead to the Stateflow
Up.
implementation.
Okay. Up. All right. There we go. I'm going to try here.
No, much further.
Much further. Okay.
Here,
There you go.
Yeah, here. So again, sorry about all this,
Sorry.
but we're back here. Can you play?
Oh, sorry. Yeah, let me start it.
Yeah, so basically the implementation here in Stateflow is very similar to what we already discussed. If you go above 43, you turn it off. If you go below, you turn it on. Now, if we go into Simulink, well, it's complicated.
Wow. Yeah, that is. I've seen that model from customers, and it gets messy sometimes when you do it this way.
Yeah, and it works. We already saw that
Yeah,
it
it
works.
works. Yeah, it's just it's hard to read.
It's hard to read, and it's even harder to modify, believe me. I have had to
Yeah,
deal
debugging
with
is hard too. Where did I go
Yeah.
wrong?
And then lastly, we will have MATLAB, which if you're more familiar with text-based languages, actually this looks okay. This is using a switch case pattern, and it's not bad. Actually, it's a very good implementation, but it's not as easy to visualize as with a graphical language like Stateflow. And in this case, we only have 2 states. Imagine if you had to do this with 10 states.
Yeah, yeah, and debugging it's not that easy. Well, I don't know.
Yeah.
But it doesn't have animation the same way, or yeah.
But one other thing that I think it's very cool, and just to make the one more comparison, here we can comment out these two blocks on Simulink and MATLAB, and we can adjust an input and see actually how does this state machine would look in C or C++ code. For those of you who don't know, if you have the embedded coder license, you can also generate code from your Stateflow model, and you will have your C implementation right next to it. You can, it's even linked back into Stateflow, so if you click on, for example, the off state here, it will show you where it is in your Stateflow state chart.
Yeah, that's nice. Great. Great. So, okay, so now let's, is this the end of this one?
Yes.
Oh, okay, great. So I'm going to take the question, I'm going to start talking about flowcharts now. So it's a little bit different than what we were doing before because it doesn't have a state, right? It's got it does have that default transition at the top, and then it goes into what we call junctions. How do you think about junctions when you?
That's a very good question, Teresa. I think of junctions as a decision point. So in a junction, to me, you could either take an action, which in this case are the curly brackets, or you could ask a question before you make a decision. So in this case, our square brackets, like is selection equal to 1? But you do not necessarily do anything inside the junction. It's just a point where you make a decision.
Yeah, so it's the stopping point for thought, I guess.
Right. It's like you're walking down a path, and then you see a sign, and before you make anything else, you just have to stop and say, like, what do I want to do? Where do I want to go?
Yeah. It's also, I also use it, you know how I had all those curved lines? That's not, like, we don't recommend that usually, so we, usually I use junctions to just straighten out my lines too.
Yeah, that's another good point. This is definitely much more readable than when you just have curly lines flowing all around your model.
Yeah. So we recommend Stateflow charts for simpler decision logic, right? So if you don't need the states, you can do this. And also you can have actions on transitions. So far we've talked only about actions inside of states, but we're about to show you something different. So we're going to add a flow chart to our fault state that we already built, and we're going to add the logic for activating a heater. So if our temperature is greater than or equal to 13, that was that time when we would jump out into standby. What we're going to do is instead, create a counter so we don't do that bouncing that we were worried about. So we'll check. If we get to a count of 4, we'll go back into standby. Otherwise, we won't. And if our temperature drops down again for any reason, we would restart our counter. And so this is all going to live within our fault state. So what's going to happen is when we enter the state of fault, we're going to immediately start essentially a different chart. It's what we call a subchart, where you have a chart within a chart kind of thing. This is the subchart of that. And it's going to take that default transition in and then go ahead and evaluate the logic. So let's go ahead and build this one too. And just in case you're building along with us. Oops, sorry. Ooh, whoa, sorry, okay, no. Okay, there we go. Sorry about that. So what I'm going to do is I'm going to go to the modeling tab, and I'm going to use this pattern wizard up here at the top, where it's going to do a if, else if, I think, yeah, just the else if, else, I think. I'm using this pattern because I have 2 things I'm checking. Because I'm using the MATLAB online thing, when I use for some reason this dialog keeps bringing up Massachusetts as a choice, which of course it's not. But I'm going to first check my temperature of the battery as the first condition and whether it's less than -13, and I'll restart the counter at that point. If that'll be my action that I'm going to take. I'll set the timer to 0 if it's less than 13. Otherwise, I'm gonna go ahead and check whether the timer is greater than or equal to 4. I think I wanted to check for 4 time steps. And then if so, I'm going to send an event. Now this is the first time I'm going to be using an event. So
ooh, an event. What is that?
An event is It's basically saying something's happening here and something else is going to pick it up. It's almost like throwing a ball to somebody else. But so I'm going to send an event like normal battery, and they're going to be listeners for that event, and when it hears that event, it's going to take action. So I'm going to send a normal battery event to happen at that point. So I've added the flowchart over here. I'm going to move it into my fault state. Or actually, maybe I'm just going to copy paste it into the fault state and make that a little bigger so it fits. OK, now I've got my pattern in here. Oh.
I noticed a couple of red lines here. What are they telling you?
Yeah, they're telling, first of all, is that I forgot that parentheses on normal battery, so it's not reachable. But first I'm going to make that inner transition thing. Now let me talk about this inner transition. This is a mistake I've made a lot, where when you get to that last circle at the bottom, it's got to restart. So it's making it recursive by saying you restart at the inner transition. So it goes back to the border and comes back in. So I'm going to change this normal battery thing to actually have its ending parentheses so it's no longer erroring. But yeah, nice catch. And also I made another error up here, temp batter, right? So I see that there's now two temp batter things up there, so I got rid of the one by fixing it.
And also, you have two parentheses in normal battery now, right?
Oh, shoot.
Oh,
no, that's an action. It's doing the action.
Oh, it's an action.
Yeah,
oh,
sending,
okay.
Yeah. And there we go.
Oh, yeah.
But once I set in the properties dialog that that's an event, it handled it appropriately. Okay, so now I've got it all set up in there. It's checking the battery, it's checking the temp, it's checking the timer, and then once I get above the timer count, I'm going to go ahead and send the normal battery event. Oh, but I don't need to send it again. Hold on, let me zoom in, and I'll check. What I'm doing is I'm checking for the event here. So on this condition, if it receives that event, it's going to go into the standby mode. So there you go. That's how we communicate outside. We send our events. So that is that example. All right, so I think there are questions this time. So we would love to answer those questions at this point. And we're also going to do a transition on computers. So I'm going to send this over to Eric.
Thank you.
So I think there was a question about adding functions into Stateflow. And there are multiple ways you can add functions into Stateflow. You can add MATLAB functions into Stateflow, and you can add Simulink functions into Stateflow. So unfortunately, we didn't prepare that example. Well, we could show that at another time, but or maybe I could do it on the fly. If we have time at the end, we'll do it.
I was thinking, I have MATLAB open, so at the end, maybe we can do a short example on how to add functions.
Yeah. Any other questions?
Nope.
I thought there was more than one.
Okay.
No
yeah, I'm not seeing any other question right now.
Okay. All right.
So yeah, let's continue for now. You will still get another opportunity to ask more questions. So don't worry about it. If you have questions, just type it.
If you asked it before and we didn't see it, please ask it again, because okay. Sorry, go ahead.
Okay, so we already saw that Stateflow is a state machine simulation environment. It is also a flowchart design environment. But Stateflow is also a state transition design environment. And maybe this is something that you haven't heard about before. A state transition table is a term that actually for me it was new until I joined MathWorks. And some of you might be looking at this and wondering, what are you? What is this? So some people just find it easier to look at their state machines in the form of a table for two reasons. First, it looks more like requirement-like. It has like this requirement look and feel. So if you're working with requirements a lot, it's probably easier to translate into a state transition table. And second, it's easier to scan for conditions and actions completeness. You will notice here, we have all of our conditions and actions listed in this table format, so it's easier to see if you are missing something. So what I want to do next is show you once more back into our main example that we talked at the beginning, how things could progress if we fast forward a few weeks or months into the development from the state machine that Teresa created. So there are two key differences here that I want to highlight. First, we talked about the fault detection. And if we go inside, we remember that our simple state machine was checking for under temperature conditions if it was too cold. And we are still checking for that here. We will have the under temperature, but we also have over temperature, we have over voltage, under voltage, over current, and a bunch of other things that could really affect the battery. So this is all put together into one single signal that is called critical fault. And if that is, if that is affecting the BMS, then we will take action inside the state machine. So I just want to quickly go over what we have right now. This is how the state machine would look like after following some protocols, doing enumerations.
Yeah, I got rid of all the enumeration. It was easier to show without that, but yeah.
I think what you did is like a beautiful way to see how you can turn something into a functioning state machine in 10 minutes.
Yeah.
And that's great when you're working with rapid prototyping, when you just want to turn like a back of a napkin design into something that is simulatable or even deployable. There's absolutely nothing wrong with just using numbers, doing it in a quick way. You can start churning code very, very quickly.
Yeah.
For some more sophisticated developments, when some other people are going to be looking at your state machines or in general at your models, you might want to make it a little bit more readable, a little bit more scalable. And that's kind of what is happening here. And I could just go and show you what's going on here. But we decided that it was a better idea to get rid of it and do it again, but this time we will do it in the form of a state transition table, just to show you one more interesting capability of Stateflow. So if we look at it, we will notice that we have our states on the left side, and we have our transitions on the top. And because we're talking about a theoretical, sophisticated process for designing, instead of starting with a hand-drawn design like we did before, we're actually considering that this time we got some requirements. In this case, we got these requirements in the form of an Excel spreadsheet, which is common in some industries. And this will going to tell us what we need to do and when we need to do it. And it's also going to give us the specifications for the input signals, but also the output signal.
Yeah. And their type, too. Looks like.
And their data type, that's very important. Because now we're dealing with enumerations, so these data types are going to become very important.
Yeah, when you want the live stream on enumerations, just let us know. They think I'm joking. I'm not joking.
Okay, so let's bring up our good friend. I would even call it my bestie, the symbols pane.
Yeah, mine too.
And we're going to be starting to add information here into the symbols pane. So we saw one way in which the symbols pane will recognize data if you just start typing it, but you can also go into create data button and just add the data preemptively, which is what I'm going to be doing here. And one other tip that I have for you guys, for example, in this case, we have our we have a spreadsheet. If you can copy and paste.
Yeah.
If you can avoid
because that's
typing,
how you get temp batter, right? You get temp batter because you didn't do the copy pasting.
That's how you get temp batter, and that's how you get many other horrible mistakes, especially when you have signals that only differ in one character from the name of the other important signal. You will get into trouble if you start typing.
Yeah,
so,
I'm with you.
Yeah, copy paste is your friend.
Yeah.
The other thing that we need to do is change the direction of the data. Teresa showed you one way to do it by just fixing it.
Get an error and then fix it. This is a much more calm way of doing it,
Right. And then the next thing that we want to do after we have set the direction of the data is look at the data type, as you mentioned before.
Yeah.
So there are a couple of ways in which we can do it, but they are not immediately available in the symbols pane. The first way to do it is with the Model Explorer. If we open the Model Explorer, we can see here that we have all the data that we already defined for this state machine. But if we look at it more closely, we will see that the type,
yeah, that's missing. Yeah.
Yeah, well, it's not missing. It's just saying that I'm going to play nice with Simulink. I will inherit whatever Simulink has.
Yeah.
But we want to replace that with the actual data types that we have. In this case, the enum contact type for the charger and inverter contactors.
And those types are defined already in some sort of data dictionary, or?
That's right. Remember that I said that this probably is like fast forward in a few weeks or months of development?
Yeah.
One of the developers actually went through the task of creating all these enumerations, bus definitions, and all the data that we needed to actually run this example.
Yeah, and that's more normal, right? Usually there is some sort of data dictionary setup that you're using. It's not
right.
Yeah, you're not always inventing it. Yeah.
And actually, we're going to see. Maybe you're wondering at this point, like, why are we spending so much time worrying about data? You will see in a few minutes how the time investment that we're doing now is going to pay off big time. So the other thing that I want to mention here, some people might have already noticed that we have this port column that has some numbers. And actually, this was present as well in the symbols pane. So if we go back to Simulink, we can see that now we created all these ports. And those port numbers that we had in the symbols pane and the Model Explorer are now going to match the port numbers that we have here, which, by the way, also match the previous implementation that we had. We should be able to complete our model in the state transition table. And now it's connected to Simulink, so everything should be working fine now. But if you are paying close attention, you will notice that I actually only set the data type for a couple of the variables. And I told you that there are two methods to do this. So the other one is through the property inspector, which plays very, very nicely with the symbols pane because you will have it in the same window. So for some quick operations, actually it's easier to do it with the property inspector. And in this case, we see how this contactor state, it's matching whatever we set in the Model Explorer.
Yeah.
For state request, we can just go into type.
Oh, that's good. Yeah, and you can use the pull down to choose your enumeration type.
Yeah, that's right.
Yeah.
Precisely because, as you said, somebody already defined these for us. We can just go to that pull down menu and just select whatever we needed. We can do exactly the same thing with Boolean, which is a very common data type. We just need to go to the pull down. If you want, you can also just, once again, copy and paste, which is what we're going to do with that BMS state.
Okay.
And there you go.
Nice.
Now, one last thing that I forgot. BMS state is our output. And actually, because it's an output, it needs to have an initial value. So that's something that needed to be done as well. But now we can get rid of the property inspector. And actually, we can also get rid of the symbols pane. We're going to need the real state to see what's going on in our state transition table. So we need to add a couple more states. We originally had 4 states. You will notice they immediately have this yellow warning sign again.
Yeah, why the yellow warning sign on these?
Yeah, that's a very good question. It's the similar case to what you saw in your state chart. It's because they are not reachable right now. We do not have any transition going into them, which we're going to fix. But the first thing that we need to fix is give them more interesting names than just state 1, 2, 3, and 4.
Yeah. And, true. Yeah, -1 too, right?
Right. And so if you notice here, actually when I'm starting to type the actions and the names here, you will see how it is suggesting me to the names that I have already defined as my variables here. So if that's the case, then I can just press tab, and then it will immediately autofill whatever I'm doing.
Yeah, that made it much easier, right? Yeah.
Yes.
So you already know the interfaces. It's so much easier to fill this stuff in, or the data type, it's easier to fill in. Cool.
Yep. So now we're getting into the requirements implementation part. Our first requirement was that the initial state shall be standby mode. If you notice here, it's a little easy to miss, but actually we have our default transition going into standby, same way as we had our default transition in the state chart.
Yeah, those filled in circles with the line going into the first.
Right. And then the second one says that when the BMS is in standby mode, the charge current should be 0. That's going to be done in the charge management, so we're not going to worry about that one for now. But this one we're going to worry about. When there is a critical fault present, we are going to go into fault mode, which makes a lot of sense, right?
Yeah, yeah.
And so if we have this thing with the critical fault, then we're just going to move into fault. And we have to do that for all the states. If you remember from the state chart that we had before, we were moving from all the states into fault in case we had some negative condition.
So on each one of these rows, the top one's the condition, the middle row is for action, I think, and then the bottom one is for the state it moves to next.
Yeah, that's a very good point, and that's something that I forgot to mention. Also because we don't have any transition actions in this particular state machine, but that's a very good point. Thanks for bringing it up, yeah.
Okay, well, I just thought of it.
Anyway, we can continue to go through our requirements and see, for example, in this case, we know that if the state request is equal to SRE charging, then we need to, oh, no, sorry, there's also one other condition. Now we're looking at the contactor states. So we know that if the request is to go to charging and the contactor is closed, then, and only when those two conditions are true, we will be allowed to move into charging mode. And I just want to emphasize how important this is, because before we were not caring about the contactor state at all, which again, for a quick design, rapid prototype, that's great. But if you're going to be driving this, I'm pretty sure you want to make sure that the contactor of the charger is actually closed before you start commanding stuff.
Yeah, it'd be pretty bad, yeah.
And then we're going to be doing something similar, but to go back into standby. If the state request is no longer charging, or if the contactor open for any reason, a fault, or maybe there's some other state that is going on, but if the contactor open, if the contactor is not closed anymore, we need to go back into standby mode.
Okay.
And then we're going to repeat the same process, but for the driving state. So we know whenever we're commanded to go into driving, and when the inverter contactor, no longer the charger, but the inverter contactor is closed.
Okay, yeah.
Then we know we have to go into driving. And actually, this is starting to look very, very good now. We just have to add one more transition. That is, whenever the request is no longer driving, or if the inverter contactor is no longer closed, then we need to go back into standby. And
there you go, live demoing, semi-live.
Yeah.
Oh, now we're running it, right?
Yeah, now we're running it. A little bit of magic is going to happen here. This is a fairly sophisticated model, so we sped up the simulation just a tiny bit for you to see. And I know there's a lot happening here, so I just want to take a second to look at some of the things that are happening, particularly these two graphs to the bottom. So this one is the SOC graph. Again, SOC stands for state of charge. So we have several methods of estimating the SOC. In this case, the orange one is the known one. Then we have column counting, and we have a Kalman filter as well. So basically, what we're doing is, at the beginning, we start in driving.
Okay, so that bottom chart on the right, that's your state chart. That's showing you what state you were in at any part of the time, correct?
That's correct, yes.
Okay, and then the top, and the one above it's, yeah, okay, got it, the state of charge.
Right. Yeah, thanks for bringing that up. I was
no,
starting to rush a little bit into this. Yeah, here on the bottom, this is the actual state of the state machine. So we're going to start in standby, but we immediately get a request to drive. Remember, drive equals discharging, so it's natural that the SOC is going to start dropping.
Yeah.
Then at some point, we arrive to wherever we are going in this test.
Like you get to work. And
yeah, you get
you plug it in.
you get to work, you park, and then you start you plug your vehicle in. So that means that now you're into the charging mode, and we can see how that is reflected into the SOC increasing until it reaches about 100%, at which point it will go into standby once more.
Great, that's awesome. Thank you.
Yep. There is one more thing actually about this state transition table that we didn't cover. So you can call this show auto chart button, and you're going to see how this implementation would look like in the way of a normal state chart. There's another thing. I've been talking about the symbols pane all this time, saying how great it is so that you do not forget your data and you make sure that everything is correct. And then I forgot to show it to you folks. So, oops. Now we want to fix that mistake. Mm-hmm. I just want to show you that here on the symbols pane, we can see all the data that was previously defined, and we are not missing anything, and we do not get any error or warning signs, which means that we are using exactly the data that we are defining, and we didn't define anything that we are not using.
Yeah, Stateflow as a error catcher.
Yeah.
Yeah, very nice.
And just to close this loop onto the state machine that we already had before, one other thing that I would like to do right now is just compare how this automatically generated state machine looks against.
Oh, super similar, huh?
Yep.
Yeah. There's the 4. Yeah, I can see the critical fault on all the ones going to the fault. Yeah, it looks similar. It's just ordered a little differently, but yeah. Cool. All right, so we're 1 hour in. Maybe it's a good time to take any final questions you might have.
Well, before that, I would say we actually have questions for our friends watching.
Oh, okay, great.
So, we've been talking to do this in state charts or to do state transition table.
Oh, and while we're doing that, there is a question. What's the difference between guard, condition, and event? So you're saying on the transition, you could either have a condition where you're checking some sort of data coming in, or an event that I'm checking for the event on the transition. I guess that's what the question is. The event is more like a broadcast mechanism, a condition within the chart usually. Actually, you can have external events coming in too. But they're both ways of checking for data coming. It's either an event data or it's condition data coming in. Does that make sense? I don't know if that answer was fully what you wanted. But
it makes sense to me.
Hopefully, yeah, I hope it makes sense to you too.
Yeah.
But we tried to use both, so hopefully that'll clarify that. Okay, so there's that question about what feels more natural to you. What was the other thing we had questions about? Truth tables.
Yeah, truth tables. We didn't talk about them during this live stream. We're already at the 1 hour marker, and there are things that we didn't have the time to include. But have you ever used a truth table in Stateflow? If you have, we'd be curious to know what you think about them.
Yeah, that's a good one.
We also have another question from.
How to add functions in Stateflow chart and call that functions. So there are different types of functions you can have in Stateflow, including a MATLAB function or a Stateflow function. And you can call them essentially by the way that you would call a function in MATLAB. Name, you would have you could use your name and your input into that function and call it that way on a transition or on an entry action. I guess it's an action. You could call the function as an action. Is that clear?
Yeah.
Yeah.
Yeah, I think maybe just.
We could show that, I suppose.
Yeah. I guess. So you will have your. There are 2 ways. You will have your pane here on the left, or you can also have your components here at the top. And if you see here, you have the option of graphical function, Simulink function, or MATLAB function. You can call this here. You give it a name, whatever. And then whenever you're using it here, you can always call your function.
Yeah.
With whatever parameters you have. And you will see it's automatically picked up by Stateflow. It now knows that this is the function name that you just gave here.
Yeah, great.
I know it's a very, very quick 30-second explanation.
Maybe we'll do the next live stream on functions in Stateflow, and then we can give it its due time, because it's a good topic. Can we have different logics in different states?
Different logics in different states.
Are you talking about different types of Stateflow charts, or?
maybe talking about decomposition.
Yeah, yeah, you can. So yeah, you can have different, like you can, just like we had the flow chart in the state, you can have a chart within a chart. So yeah, you can have, oh, right, or you can do that too.
I was thinking if they are talking about the AND versus OR decomposition.
Yeah.
So do you want to do a quick explanation of the difference between these two?
Not really. Well, they'll run at the same time the way that we have it here. These are both parallel, running at the same time, but I don't know, how do you want to describe AND and OR?
Yeah, I think you already described it. If it's
this is an AND, they're both happening, right? So they're AND.
Yeah. And just to, maybe I did this very quickly. You have this, if you right click on the canvas, you will have this option of decomposition that tells you it's exclusive or it's parallel AND. Right now we have selected an AND decomposition, but you can go back to an OR decomposition in which one is going to run after the other. Usually you use that whenever you have to change things. But actually, I don't know what we're, oh no, we don't have the other example open, sorry. I thought we had an example with an AND decomposition that I could show.
Oh, I think, well, yeah, we're getting late. Oh, can I, oh, and yeah, we did want to ask about features you like to see in Stateflow. Can I quickly jump to like the last two slides though? Because
oh yeah, of course.
I don't want to lose people before we say these things. I mean, you already showed code generation, so you should know Simulink and Stateflow have the same code generation tool that's backing both of them. So just like Simulink, it works the same way. You get generated code, you can deploy code onto the same targets. It's all kind of in the back, the same thing going on. Also, like Simulink, it works with our verification workflow, and this is particularly important for things like coverage. Like, am I ever going to get into this state? You can use the Simulink coverage, especially these really complicated Stateflow charts. You can build, you can use Simulink tests to build a bunch of tests to handle your functional testing. Are there any of those other ones you wanted to bring up? Right now, I mean, there's a ton. Like we have a lot of testing for all the way along your workflow. So when you're testing requirements, testing your model, testing your implementation, testing your generated code, it works out the whole way through.
Mm-hmm. Yep.
I think that's it for me. Oh, any other questions other than the different logics question?
I'm seeing if we have any other question.
I guess not.
If not,
I think
well,
we lost them.
maybe. I mean, we were just babbling at this point, and people have already signed up. But if you're still here by some miracle, one last thing that we would like to ask is what features you would like to see in Stateflow next? What things do you think are possible that we are not doing yet that you would appreciate to see in the future? We would really be curious to know about this.
Yeah, let's make it a conversation. Yeah, definitely. All right, thank you guys. We really appreciate your time, and we really enjoyed being here with you.
Yep, definitely.
Yeah.
Have a good day,
Bye.
everyone. Bye.
I don't know. Yeah.